Okay, hopefully no more feline interruptions. I've sort of extended the problem we had last time to add a new thing, a charge little q, which is going to be placed down here. And the problem now is to find little q if the electric field at P, this point here, has no vertical component. So the electric field at P, I'm going to write this way. Electric field at P, let me write electric field at P. Okay, this is the net electric field at point P, is going to be equal to the electric field of charge 1 at P plus the electric field of charge 2 at P. This is a case where we have two different charges generating electric fields here, and the net electric field is the sum of those two, or as it's often called, the superposition. What's 1 and what's 2? That is what's 1 and what's 2. So from part 1, or from the part I just did, I knew that the electric field of 1 at P, we weren't calling it 1 in the previous video, but now it is going to be K times big Q over, I'm just remembering this from the previous video, so there's no magic involved in this, to the 3 halves, times W I hat plus H J hat. Okay? So that's the electric field due to 1 at P. Now I want to find the electric field due to 2 at P. So what I'm going to do first is basically just follow the same process here, right? So I'm going to start over here and draw a little line. That worked pretty well, actually. And make that my vector of R from 2 to P. I'm going to call it that. Okay, so this is a vector that goes from charge 2 to point P. So again, just to be super careful, I'm going to get my components out, or get this all nicely organized. So horizontally, we go negative 2w. Again, remember, x is to the right, so if we're going left, that's negative 2w, and our horizontal unit vector is I hat. And then we have plus 2h j hat. Okay? Now, the magnitude of that, magnitude of that is going to be the square root of the sum of the squares of the two components. So like that, just Pythagorean theorem. So 4w squared plus 4h squared. And I'm going to go ahead and say that that is equal to, I'm going to pull the 2 out. So 2 square root w squared plus h squared. Okay? And finally, the unit vector pointing from Q to P. So remember, that's just the short, cute little vector that has a magnitude of 1. Okay, so R hat to P is going to be the R vector from 2 to P, this guy up here, divided by his own magnitude. Okay, so what we get there is we get negative 2w I hat plus 2h j hat over 2 square root w squared plus h squared. And those 2's will cancel, so why not do it? Okay, so negative w I hat plus h j hat over root w squared plus h squared. Okay, so that's your unit vector pointing that way. And now we are ready to go ahead and plug this into the electric field version of Coulomb's law, which looks like regular Coulomb's law, except it just gives you the electric field, and you take out whatever the test charge at P would have been. So that's going to be K times our little q over R to P. And technically, this is the charge of Q of 2 we're talking about here if I'm writing in this form, but you ought to understand what I'm doing, I hope. And so R hat to P. Okay, so what we do now is we go and we do this as a, let's see, we're going to do this as K times the charge of 2, which is little q, divided by, and then R2P squared. So we take this here, and we're squaring it. So that's going to be 4, is going to be the 2 squared, and then you're just going to get w squared plus h squared. Okay, so that's everything in here. And this, what I've just parenthesized is this here, which is your magnitude. Okay, and so now what's left is just taking the hat vector to point it in the right direction. So this is going to be then negative w I hat plus hj hat gets multiplied by all this. And let me move that parentheses. There we go. And then we go root w squared plus h squared. Okay, so what this is going to give us now, and I'm sorry, this is the electric field of 2 at P. Let me, 2 at P to be clear, okay? So now we get KQ over 4 times w squared plus h squared, and I'm taking this w squared plus h squared and adding, or not adding, but multiplying in the w squared plus h squared to the 1/2, so we get that. And then we go negative wi hat plus h j hat. Okay. Now, what we need to do next is add these two together. So add this here, which is our electric field of 2 at P, to our electric field of 1 at P, and to get the net electric field at P. So the electric field at P is going to equal, so I'm taking this equation here and just plugging in. So this 1 at P is going to be KQ over w squared plus h squared to the 3/2, okay, times wi hat plus hj hat. Now, what I'm going to do here, you'll notice that this here, oh, wait a minute. Nope, never mind. So I'm going to have to, let's see. Well, tell you what, let me scooch this over. Dunk, and move. Okay, so, okay. So that's going to be this plus k little q, no, not big Q, sorry, little q over w squared plus h squared, and this is going to be, I'm going to pull this 4 here out to the side, so I'm going to, well, no, I'm not. I'm going to go with 4 out there. So I'm just going to write this in to the 3/2 on the denominator, and then all times negative wi hat plus hj hat. Okay, so that's, this here is our net electric field, and we want this to have no vertical component, right? So we want it to have no vertical component. So let's just erase all this, and there we go. And so this guy, to have no vertical component, the stuff that's got j hats on it has to add up to 0. So what I'm going to do here actually is I'm going to just rewrite this up here. E hat, the net, or sorry, E vector, the net electric field at P, and I'm going to take a K over this denominator out. Okay, I'm just going to factor that out. So w squared plus h squared to the 3/2. Okay, so that takes care of, let me just get, I get a different color to scratch this stuff out. Okay, so now what I've got left, going back to blue, I've got, for the one side, I've got the capital Q times wi hat plus hj hat, okay? And then for the other one, I've got little q over 4 times negative wi hat plus hj hat. Okay, and so again, what I'm doing, this is what we've been doing since the beginning of the year, adding vectors. You break them into components and you just add together, and terms with i-hats add up just like they would if there was something else, some other common factor in them. So the electric field at P, I'm going to still get K over W squared plus H squared to the 3/2, and then I'm going to gather up my terms with i-hats and with j-hats. So on the i-hat stuff, we're going to have QW times i-hat, right? So QW i-hat plus plus Q over 4 times negative W. So this is going to be minus QW over 4, okay? And that's my entire i-hat term there. And then for the other way, we're going to go with, for the vertical stuff, we're going to go with Q big H, or QH here, and then this is a positive H here, so plus QH over 4 J hat. Okay, And in order for this to have no vertical component, okay, what that means then is that this term in here, which is your coefficient or your what gets multiplied by your vertical unit vector, right, has to equal 0. So I'm going to at this point stop, I'm going to stop writing out the whole thing and just say we want the vertical component of this whole thing to be 0. So we're just going to take out what's in parentheses here and set that equal to 0. So QH plus little qh over 4 has to equal 0. The h's obviously drop out, and so what you get is little q plus, or sorry, big Q plus 1/4 little q has to equal 0, which means then we want to find q, right? So the answer is q has to equal negative 4q, or little q has to equal negative 4 times big Q. Okay, so I hope this gives you some idea what's going on here with this stuff. Yeah, this is not hard to learn. There's nothing to be ashamed of if you've forgotten this, or if you learned it earlier and it's left your head, whatever, or if you never quite mastered it earlier. But you really want to, because the next several units are going to deal with fields and how they add up as vectors. And if you're not able to do that, you're going to be in a world of hurt, even if you understand the other stuff we're teaching you. So there you go.